The point estimate was 16%. Plus and minus 0.0, let's go 028. That'll be good enough. And once we do with the adding and subtracting, that'll be the integral. So the population percentage of people who think trains is safest would fall in between these two percentages. That would be 8.8188, I can say it. What's the one you subtract? Good to go on that one? Okay. Program, there's a little catch in the program too, if I remember correctly. Yes? P is successes, Q is failures.
Yeah, why is there a half though?
Oh, because it's coming from the sample. Like we have mu for population mean and X bar for sample mean. So the symbol tells me whether it's coming from a sample or versus the population. P hat's the sample. Sample. If it doesn't have the hat, it's referring to the population. So this interval is for the population. Okay, let's run the program and see where the tricks are at. The one prop Z int, yep. Let's see, I'll use this one here. Oh, it shouldn't be. I'll put this one up so you guys can go. Okay, see what the program needs here. Stat, test, one prop. Remember, no tests in this chapter. Don't stop on any of these beginning ones. What direction do I need to be at here? Flat usually doesn't work. Not bad? Alright. 2 samp Z int, 1 prop Z int. Okay, X. What does X represent? Number of successes. Do I know how many successes I had? That's a percentage of successes. I heard 149.6. You would be correct, because if I know I've got 16% successes and I multiplied by the sample size, we got 149.6. We're going to get an error here because the calculator is going to say, well, you can't have 149.6 successes. Get your act together. How many successes, because the 16 is probably what's rounded, how many successes do you think they actually had? 150. Because he would round normally here. So, what you can do, you can even type that in, say we didn't do that up there, so you forgot you did it, you could do 935 times 0.16. Oh, I hit something wrong, didn't I? Oh, that's right. 935 times 0.16. I see it's a decimal. I'll get an error. If you go try to run it, it'll say error. Go back and say, oh, that must be 150. N was 935. And then it's confidence level. So the only catch in here is that X has to be a whole number. And we did 98%. Calculate. And we should match pretty close. So, the one thing to remember on the program is that X must be a whole number. You have a decimal on the X. You can't have a decimal there. Oh, the sample size was 935. You can't have more successes than you had samples. That'll cause an error too. Okay? So, and you use regular rounding rules. Yes, because you'd want to keep that as close to the percentage as you could get. So the only time you round up is on minimum sample size. Okay, I want to do one more where they give you slightly different information. And then there's a minimum sample size. We're done. So we're just still there. So we'll go through this one a little bit quicker. Let's see, not that, not that. Gotta find one. Numbers. 1 second. Okay. A study of 34,000, it's a big sample, American adults found that 4,080 had low levels of iodine. Okay. I don't know why that's important either. Low iodine levels. Iodine. Construct the 90% confidence interval for the proportion of all adults with low iodine. So right away when I do one of these on the test, I would look to see what am I finding the confidence interval for. And in this case, again, it's today, proportion. That's the P business. So that's going to tell you to go to the proportion section on your note card. Not the mean for big samples, not the mean for small samples, but proportion. Okay. I'm going to say the sample size is big enough. 34,000 seems kind of large. But let's see. We need to do N times P hat and N times Q hat. What's my N? 34,000. It's a big sample. P hat. Did I give you P hat? I didn't give you P. What did I give you? What is this? X. That's the number of successes I gave you. How do you turn X into a P hat? X divided by N. Well, what's going to happen here? What am I going to get? I'm going to get X back. N times P hat is telling me how many successes I have. 4,080. I don't need a calculator because the 34,000 cancel out. Which is okay because it's bigger than 5. And then N, do I really need to do the N times Q hat? If I had 4,080 successes, I need failures here. What would you do? Yep, subtract the 4,080 from the 34,000, which is going to be well over 5. I'm just going to say okay. So it's definitely, the sample size is big enough to move on. So we'll calculate max error. Z-score, square root, P hat, Q hat, over N. Okay, I gave you 90%. Does anybody remember the Z-score for 90%? It was in our table because it's one of the common ones. Very good. Well, I guess I am going to need that number. P hat, we could put the fraction in here. Oh, you got 0.1. You did the decimal already? Okay. So then Q hat would be 0.8. 0.88. Is everybody okay with where those came from? P hat is just your number of successes, 4080, over sample size, 34,000. Which they're telling me comes out 0.12 if you divide it on a calculator. Subtract from 1. 1 minus 0.12 gives me 0.88. Okay, over sample size, 34,000. And then it's calculator work. I got 0.002. Actually 003 if I go there. How about you? And then P hat plus and minus the error is the 0.12 plus and minus 0.003. That error is so small because our sample size was so large. The bigger the sample, the more accurate you're going to be. So look at how small this interval is going to be. Is it 117? And then the program, you only got to feed it 3 things: X, N, and the confidence level. What's the X in this problem? The 4080. We don't even have to do it. It's going to be fine. We can just move on. Okay, the last thing you need is another minimum sample size formula for proportion. So, on your note card, make sure you distinguish between minimum sample size for doing sample means, actually population means, versus minimum sample size for proportion.
Where to decide whether that's proportion?
It has to say proportion. See how I... Proportion. Got to tell you what you're working with. It's not a guess.
Can we stop? Because I just ran out of paper.
Oh, I got one little formula, then we're done.
Oh, that's like...
Minimum sample size, 2 sentences. I put that note in the wrong spot. That first page there, go back to that. Where did I write that? This little if P hat is not known, we're going to have the sample. We're going to know P hat. Get rid of that. It belongs here. Cancel that out right in that box. Beautiful. That belongs here with the minimum sample size. Okay. P hat. Q hat times the fraction z-score over error squared. This is the one, if P hat is not known, use 0.5 because that will create the biggest possible sample. This is where I wanted that note. Okay, this is it. So, you want